Space travel. It's the final frontier, the ultimate adventure that has captured human imagination for generations. It's not as easy as it looks in the movies, folks. Hollywood makes it seem like a walk in the park, but the reality is far more complex and challenging. You can't just bolt a couple of jumbo jets together, slap on a rocket, and call it a day. The engineering behind space travel is a marvel of human ingenuity and perseverance. Why? Well, for starters, there's no air to push against. In the vast emptiness of space, traditional methods of propulsion simply don't work. Traditional engines, like the ones in your car or a jet plane, work by pushing against something. They rely on the presence of air or another medium to generate thrust. Air, water, you name it. These engines take in air, mix it with fuel, burn it, and blast out hot gas to create movement. They take in air, mix it with fuel, burn it, and blast out hot gas. This combustion process is what propels the vehicle forward, whether it's a car on the highway or a jet soaring through the skies. That blast creates thrust, pushing the vehicle forward. It's a simple yet effective principle that works perfectly within Earth's atmosphere. But in the vacuum of space, there's nothing to push against. The absence of air or any other medium means traditional engines are rendered useless. It's like trying to swim in a pool of marbles. No matter how hard you try, you just can't get any traction. You need a different kind of engine, one that brings its own push to the party. This is where rocket engines come into play, designed to work in the vacuum of space. And that, my friends, is where rocket science gets really interesting. Rocket engines carry both fuel and an oxidizer, allowing them to create thrust even in the absence of air. This self-contained system is what makes space travel possible, enabling us to explore the cosmos and reach for the stars. So, how do we get around in space? With rockets, of course. These incredible machines are our ticket to exploring the final frontier, pushing the boundaries of human knowledge and capability. But not just any rockets. These are marvels of engineering, designed to defy gravity and propel us into the great unknown. Each component, from the engines to the fuel tanks, is meticulously crafted to ensure the rocket can withstand the immense forces it will encounter. Rockets work on a simple principle: Newton's third law of motion. This fundamental law of physics states that for every action, there is an equal and opposite reaction. Every action has an equal and opposite reaction. In the context of rockets, this means that when the rocket expels gas out of its nozzle at high speed, it generates a force in the opposite direction, propelling the rocket forward. In this case, the action is the expulsion of hot gas out of the rocket's nozzle. The reaction? The rocket goes the other way. Pretty cool, right? This principle is what allows rockets to break free from the Earth's gravitational pull and venture into space. The reaction? The rocket goes the other way. Pretty cool, right? But there's more to it than just the basic physics. The journey to space is fraught with challenges and requires overcoming numerous obstacles. But there's a catch, a big one. The amount of fuel required to achieve the necessary thrust is staggering. These rockets need a ton of fuel to generate enough thrust to escape Earth's gravity. And I mean a ton. We're talking about massive tanks full of highly flammable, carefully calculated concoctions that make fireworks look like sparklers. And I mean a ton. The fuel itself is a marvel of chemistry, designed to burn efficiently and produce the maximum amount of thrust. Engineers spend countless hours perfecting these fuel mixtures to ensure they provide the necessary power without compromising safety. We're talking about massive tanks full of highly flammable, carefully calculated concoctions that make fireworks look like sparklers. Handling and storing this fuel is a delicate process requiring stringent safety protocols to prevent accidents. And even with all that fuel, we're still limited to a snail's pace compared to the vastness of the cosmos. Space is unimaginably vast, and even the fastest rockets take years to reach the outer planets. But despite these challenges, the pursuit of space exploration continues to drive innovation and inspire future generations. The dream of exploring the stars pushes us to develop new technologies and overcome the limitations of current rocket designs. Who knows what the future holds? Perhaps one day, we'll find a way to travel faster and farther than ever before, unlocking the mysteries of the universe. Until then, each successful launch is a testament to human ingenuity and determination. It's not just about going up, it's about pushing the boundaries of what's possible and reaching for the stars. Now let's talk about speed, or rather, the lack thereof. We often find ourselves in a rush, whether it's hurrying to work, racing to meet deadlines, or just trying to keep up with the fast pace of life. But sometimes it's worth slowing down and appreciating the world around us. You see, there's this thing called the speed of light. It's not just a concept from science fiction, it's a fundamental constant in the universe. Light travels at an astonishing speed of approximately 299,792,458 meters per second. That's nearly 300,000 kilometers per second. Maybe you've heard of it? It's kind of a big deal in the universe. Light speed is the fastest speed at which information or matter can travel. It's the ultimate benchmark for speed, and nothing in the cosmos can surpass it. And thanks to a rather brilliant fellow named Albert Einstein and his theory of special relativity, we know that nothing, and I mean nothing, can travel faster than light. Einstein's groundbreaking work reshaped our understanding of space, time, and the very fabric of reality. It's the ultimate cosmic speed limit. Imagine trying to break that limit. It's simply impossible. Even the fastest spacecraft we can imagine are mere snails compared to the speed of light. Think of it like this. Imagine the universe as a giant cosmic highway. On this highway, everything from particles of light to massive celestial bodies is moving, but all within the bounds of this universal speed limit. And on this highway, there's a sign that says, speed limit, 299,792,458 meters per second, no exceptions. This speed limit is enforced by the very laws of physics, and trust me, you do not want to get a speeding ticket from the universe. The consequences of trying to exceed this limit are not just fines or penalties. They involve the very breakdown of the laws of physics as we know them. So next time you're in a rush, remember that even the universe has its limits, and sometimes it's okay to slow down and enjoy the ride. Now I know what you're thinking, but Neil, you say, what about warp drive, wormholes? Surely there's a way around this pesky speed limit. And to that I say, keep dreaming, my friend. While these concepts are fascinating and make for great science fiction, they're still firmly in the realm of speculation. Warp drive, which involves bending spacetime itself, has some serious theoretical hurdles to overcome. Wormholes, theoretical tunnels through spacetime, are even more speculative. We haven't even found one yet, let alone figured out how to build a spaceship that could survive the trip. So, for now, faster than light travel remains the stuff of fantasy. But hey, that doesn't mean we can't keep exploring the possibilities, right? Section 5, light speed. It's not a suggestion, it's the law. Now, back to the speed of light. Some folks seem to think it's more of a guideline than an actual rule. Let me assure you it's not. The speed of light is constant. It doesn't matter how fast you're moving or in what direction, the speed of light is always the same. It's like the universe's way of saying, look, I made the rules here, and you're just going to have to deal with it. And trust me, you don't want to mess with the universe. It has a way of putting you in your place. Section 6. So, what exactly is light? Anyway, light, my friends, is more than just what allows us to see. It's a fundamental force of nature, a wave, and a particle all rolled into one. It's the universe's way of communicating, of transferring energy across vast distances. Think of it like this. Imagine you're at a crowded concert and your favorite band starts playing. The music, the energy, the excitement, it all travels through the crowd in waves. Light is kind of like that, only instead of sound waves, it's electromagnetic waves. These waves, oscillating electric and magnetic fields, travel through the vacuum of space at, you guessed it, the speed of light. Section 7. The speed of light, a universal constant. Now you might be wondering, why is the speed of light so important? Well, for starters, it's woven into the very fabric of the universe. It governs everything from the way atoms interact to the way stars shine. It's the ultimate yardstick, the cosmic ruler by which we measure distances across the vast expanse of space. When we talk about light years, we're talking about the distance light travels in a year. It's a mind-boggling concept, I know, but the universe is a mind-boggling place. Section 8. Beyond the horizon. The quest for knowledge continues. So, can we travel faster than light? For now, the answer seems to be a resounding no. But that doesn't mean we should stop asking questions, stop pushing the boundaries of what we know. The pursuit of knowledge is a journey, not a destination. And who knows what wonders await us as we continue to explore the cosmos. Maybe one day, we'll unlock the secrets of faster-than-light travel. Maybe we'll discover new physics, new technologies that will make the impossible possible. Section 9. The uncharted territories of the universe. Until then, we have the vast and mysterious universe to explore, even if it's at a less than warp speed pace. There are countless stars, planets, and galaxies out there, each with its own story to tell. We've only just begun to scratch the surface of what's out there. And with every new discovery, we come one step closer to understanding our place in this grand cosmic scheme of things. So keep looking up, keep exploring, and never stop asking questions. Section 10. Imagination, the engine of scientific breakthroughs. Because sometimes the most incredible journeys begin with a single question. What if? What if we could travel to distant stars? What if we could unlock the secrets of the universe? What if we're not alone? These questions may seem like the stuff of science fiction, but they're the seeds of scientific discovery. They're the spark that ignites our imagination and drives us to explore the unknown. Section 11. Conclusion, keep looking up. So the next time you look up at the night sky and see those twinkling stars, remember this: we may not be able to outrun light, but we can certainly keep chasing after it. We can keep exploring, keep dreaming, and keep pushing the boundaries of what we think is possible. Because the universe is full of wonders, just waiting to be discovered. And who knows what we might find if we just keep looking up.